All right, we are going to go ahead and get started with a linear equation that helps us graph onto a coordinate plane. So what we need to think about is we have to think about this function here that we have in the y equals mx plus b. Now this function really is just the basis formula of what this function we've already received is standing for. So that means that this y equals here is just telling us that this is going to be a linear function, which means we're going to be able to initially graph this equation in a line because we already know that it's set into the y equals form. Okay, so then we have to think about, okay, what is the value of my mx here? I have to think about x is just to the power of 1 because it's just a plain old x. So that's also another reason I know that it's going to be graphed into a line. So this m here, this m always will stand for slope. So slope just tells me how fast my line is going to be going up or how slow it's going to be going up or down, depending on if it's a positive or negative number. So this m will always be matched with the number that is in front of the x. And the x just tells me that we are gliding, this line will be gliding across the x-axis. So anything that this slope does will go across the x-axis, whether it's positive or whether it's negative. And then finally we have this b here, and b just stands for the y-intercept. And it tells us where our line is going to begin, where it's going to start by crossing the y-axis. So we have to definitely make sure we know which of the two lines is going to be our y-axis and which is going to be our x-axis. So this b is represented by a constant number. Constant number just means a whole number. It could be a fraction, it could be positive, it could be a decimal. So this is just going to be a rational whole number or just a rational number in general. So we're going to go ahead and get started by taking this equation. We know it's an equation because it has an equal sign. We're going to take this equation and we're going to graph it, always starting with our b here. So let's go ahead and flip to our next page. And our equation was y equals 3x plus 1. Again, I'll state that we're going to start with the y-intercept, which will always be our constant at the end. So y-intercept goes with the y-axis, which I'm going to highlight in the green. So that way we know that this is the y-axis. So then I'm going to go ahead and label this other line, our horizontal line, as the x-axis, because we know that y is always vertical and x is always horizontal. So since this 1 represents the y-intercept, it has to be graphed with using a point, or essentially just a dot, onto the y-axis. So 1 is positive, so we know that positive numbers go up and negative numbers go down because of the y-axis. So the 1 is positive, so I'm just going to plot a 1 on top of the first line, because remember we count by ones here. So I can see that this 1 was plotted here with just a dot on the 1, that is the line on the y-axis. So now I can focus on my slope, which is going to be 3. So our rule of thumb for our slope is always going to be rise over run, because we're always going to rise up the y-axis and run along the x-axis. So 3 is positive, so we're going to rise positively up the y-axis. So I'm going to rise 1, 2, 3. And I don't have a number that it's over, so anything that's a whole number I know can be divided by 1, and I'm going to get the same answer. So that means that initially I have an imaginary 1 sitting underneath this 3. So it means I'm going to run 1, which is going to be right here on this x-axis. Since I can plot another point here. I'm going to rise again, 3, 1, 2, 3, and I'm going to run 1 and plot another point. 1, 2, 3, and run 1 and plot another point. Now these points are going to go ahead and they're going to be connected by a line because we already talked about how this is linear. So I'm going to connect these in a straight line the best I can. My line will never be straight on this, but that's okay. You get the general idea. I always put arrows on the ends of my line because this line is never ending. It's a function, so therefore it's continuing on and on. So I can just make sure I put arrows on to represent that I'm going on forever. So let's go ahead and try our next hand at this one. We already have it in the y equals mx plus b form, so we're going to go ahead and skip over to our graph, and we have y equals negative 2x minus 2. Again, we're going to focus on this negative here. The negative 2 is our constant. Remember, we're looking at the y-axis for our y-intercept. So I'm going to go down to negative 2, 1, 2, and I'm going to plot a point there for the negative 2. Now, the x-axis is going to go ahead and go horizontal again. My slope is a negative 2. And so I'm going to have to, instead of rising up, I'm going to go ahead and rise down because I have my rise over my run. So I'm going to go ahead and rise down, and then I'm going to run positively because a negative divided by a positive will give me negative. If I ran negatively, then I would be doing a negative divided by a negative. That would give me a positive, and I'm not looking for a positive. I'm looking for a negative. So I'm going to rise down 2. And I'm going to run 1 because, again, that negative 2, anything divided by 1, will make my same number that I already have. So I did go down by 2, and I ran over 1 positively because, remember, positive numbers go to the right and negative numbers go to the left. I'm going to go ahead and rise down 2 more, and I'm going to run 1 and plot my point. Erase my little dashes here, and I'm going to connect my line as straight as I can, put arrows on the end of it because it's a never-ending line, and there I have my next function. Again, this one is already set up in y equals mx plus b. If I wasn't set up in y equals mx plus b, I'm always going to solve for y first because I want to make sure y is by itself, it's isolated. So I have y equals 7x minus 4. So I have my y-axis, and I have my x-axis. My 4 here is negative, so I'm going to go down 4 spaces to represent my y-intercept here. So my slope this time is a positive 7, so I'm going to rise 7, and I'm going to run 1 because 7 over 1 will give me 7. 7 divided by 1 will give me 7. So I'm going to go ahead and rise 1, 2, 3, 4, 5, 6, 7, and run 1 and plot my point. Now I don't think I have enough space to run again. 1, 2, 3, 4, 5, 6, barely. And run 1 more. So we can see that this slope is very steep. We would need a lot of space to keep this line moving. So I'm going to go ahead and graph this. Put arrows on the end of it. And I have a very steep positive slope. So now it's time for our challenge question. Our challenge question goes along with a linear equation that's been mixed up. So I have to make sure that I'm solving for the y equals mx plus b. So what I would do is I would go ahead and solve for this negative 3y. So that means I'm going to move my 3x over to the other side. So if I subtract, move this here. If I subtract 3x to both sides, remember this 3 cannot be combined with the 12 because of this x that it's attached to. So these disappear, and I have negative 3y equals, I'm going to just rewrite that 12 because it's already there, and attach this negative here that I brought over. Now I have to get this y by itself, so I'm going to go ahead and divide by negative 3 to both sides, and I'm going to solve. So I can write this as this, or I can write this as divided by negative 3 and divided by negative 3 individually, so I can see what these would be by themselves. So I'm going to rewrite my equation to have y by itself. I'm going to flip-flop these variables, this variable to go in front because that's how I've been setting it up with y equals mx plus b. So if I think about how I would divide, these negative 3's would cancel out, and therefore, since they're both negative, that means that my x is now becoming positive, so I have positive x in front. And I have a positive and I have a negative here, so that means my leftover here would be a negative 4. So this x here I have in front is, remember, whenever I have an x standing by itself, it's just like I have a 1 standing in front of it, an imaginary 1. So I'm going to take this imaginary number here, and I have y equals x minus 4. So I'm going to plot that negative 4 on my y-axis because I need to make sure that my constant is plotted first in this case. So I'm going to go ahead and do 1, 2, 3, 4 and plot my point. I have an imaginary 1 in front of that x, which means I have an imaginary 1 underneath that x, giving me a 1 over 1, leaving me with 1 again. So I'm going to go ahead and rise 1, run 1. Rise 1, run another 1. I have a lot of space here. Rise 1, run another. Rise 1, run another. Rise 1, run another. And I could go on for a long time and fill in all this empty space here, but why waste my time when I already know where I'm going? It's always important to at least do 2 to 3 points, preferably 3. And there you have it. Our challenge question has been graphed.